Okay, so even functions are symmetric over the y-axis. This is how it looks fancy. It's the y value at x is the same as the y value at negative x. So like here, when x is 1, I get this y value, and when x is negative 1, I get the same y value. When x is 2, I would be up here, and when x is negative 2, I would also be up there. So it's got this lovely symmetry. And this guy has it also. So when x is 1, I'm here. When x is negative 1, I'm at the same height. And so notice that I drew here, it looks kind of like the y equals x squared. And you're like, yeah, that's even. But be a little bit careful. Even degreed polynomials are not necessarily even functions, and even functions are not necessarily even degreed polynomials. It's kind of a little bit of an annoying term overlap. It's because what if I had the graph y equals x minus 2 squared? That would be x squared plus something, 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 right? But it would be shifted to the right, and so therefore it doesn't have the y-axis symmetry over the y-axis. It has symmetry over this line here, so it doesn't count as an even function. But it's an okay way to remember it, like which one's which. Oh yeah, this one is the one with the y-axis symmetry, so f of x equals f of negative x. Here, for odd functions, they have origin symmetry. So again, I drew an x cubed, which has an odd power, but again, if I took like x cubed plus 1, that has an odd power, but it doesn't have that symmetry over the origin anymore. So be a little bit careful. And it doesn't have to be a polynomial to be odd. This guy here has that odd symmetry also. So like when x is 1, I get this y value, but when x is negative 1, I get the negative version of that y value. So like this is 5, and down here is like negative 5. Whew. So that's how that works, and we'll do some examples.